Our next goal for rational functions is to answer this question. How does excluding an x value from the domain of a rational function affect the graph? There are two ways in which this exclusion can manifest itself on the graph. One of those ways is a visual hole in the graph. The other one of these ways is called a vertical asymptote. So in this video, we will explore what happens on the graph when x values are excluded from the domain of a rational function. Let's look at our first rational function. We have f of x equals x minus 5 divided by x minus 6. First, we are asked to find the domain of the function. To find the domain of the function, we will take the denominator, set it equal to 0. We will solve that equation for x. I will add 6 to both sides to get x equals 6. This, remember, is the problem x value that causes the denominator to become 0. So we want to exclude that from the real number line. So we want to exclude this x value. So we're going to draw our number line. We will put 6 on the number line. We will put an open circle to mean not included. And then we will include every x value except for 6. So our domain becomes negative infinity all the way to 6, but not including 6. And then again from 6 to positive infinity. And we have a hole or a gap, so we'll put a union symbol. Recall that this means that every x value that's included except for 6 can be used in the function. So anything to the left of 6, anything to the right of 6 can be used in the function in place of x, but x equals 6 cannot be used as an x value in the function. Let's test out again why x equals 6 cannot be used in the function. If I were to plug a 6 in to the equation in place of x, everywhere I see an x, I put parentheses, and I'm going to drop a 6 into the parentheses. The denominator becomes 0, and the numerator becomes 1. 1 divided by 0 is undefined. So we are not allowed to put a 6 into the function because it does not give me a real number out for y. Now what does this look like on our graph? When we go to the graph and we look at x equals 6, what we notice is that the graph is actually broken up into two parts at x equals 6. If I were to draw a dotted vertical line at x equals 6, you will see that the graph is split into two parts to the left and to the right of x equals 6. But there is not a point plotted for x equals 6. So on the graph, you don't have 6 comma some y value plotted because 6 goes into the function and gives me out something that is undefined. What we have at x equals 6 is what we call a vertical asymptote. So it is a dotted vertical line that separates the graph into two separate parts. Notice the behavior of the blue part of the actual graph on either side of that vertical asymptote. The graph actually seems to go parallel or right alongside near that vertical line, either going all the way up or going all the way down as we get close to x equals 6 on the graph. The graph itself goes practically vertical alongside of that vertical asymptote. Another way that domain issues can represent themselves on the graph is a hole in the graph. So let's say that we were asked to find the domain of this rational function. In order to find the domain of this rational function, we would take our denominator, which is x squared minus x minus 2, and we would set that equal to 0. And then I'm going to solve for x. In order to solve for x here, I would have to factor to solve this quadratic equation. I have x and x. My numbers I need are 2 and 1. Our signs are opposite. Set each one of those factors equal to 0. Solve for x. So the domain will be excluding those two x values from the number line. So I'm going to put -1 and 2 on the number line. I'm going to put open circles to say that -1 and 2 are excluded or not included as part of the domain. And I want to represent all of the x values to the left, in between, and to the right as allowed values for x. So the domain are the x values that we are allowed to put into the function. So from -infinity all the way to -1, and then everything between -1 and 2, and then every x value to the right of 2 is allowed to go in. So I have from x equals 2 to positive infinity. I have gaps or holes at -1 and 2, so we will put union symbols for those, in between those interval notations. So the question comes as to what are the physical manifestations on the graph if we're not allowed to use an x value of -1 or 2, what does that do to our picture? So it looks like at x equals 2 we have a hole in the graph, but it is excluded still from the graph, but it is excluded as a whole. Notice that the graph comes right up to that x value of 2 and then keeps going right along on the other side. However, at x equals -1, it looks like we have that vertical asymptote. So we have that kind of that dotted vertical line that is separating the graph into two totally separate pieces. And we notice that on either side of that vertical line, the graph starts to go vertical. So as we get close to x equals -1, the graph goes parallel, or starts to go vertical along that vertical line. So there are two possibilities for how an x value can be excluded from the graph. It can be excluded as a vertical asymptote, or that x value can be excluded as a whole. How do we determine the difference? To determine the difference, we go back up to the original function and we factor top and bottom. So we have x minus 2, that's already factored as much as possible. The denominator will factor as x plus 1 times x minus 2. And now we want to cancel if possible. So we are going to reduce this fraction. Notice that x minus 2 and x minus 2 cancel. We're left with a 1 at the top of the fraction. So when we cancel common factors, notice that it's x minus 2 that ends up canceling out. You will have a hole at the canceled factor. So if the factor cancels, you have a hole in the graph at what makes that factor equal 0. So x minus 2 cancels. What would make x minus 2 equal 0? Well, we said x equals 2. So we end up with a hole at the canceled factor. So whatever would make that canceled factor equal 0, that's where we have the hole. Notice that x plus 1 did not cancel out. X plus 1 stays. Whatever factor does not cancel out of the bottom of the fraction, whatever makes that factor equal 0 will become a vertical asymptote on our graph.